Welcome to our online class, Introduction to Urban Drainage. We all know that, and recently or lately, many cities in the world have been suffering from urban disaster. Some of these urban disasters have been linked to flood due to climate change impact and due to the high rate of urbanization. And we have all noticed that, and a number of buildings has increased. Roads have increased during the late 21st century. All this urban infrastructure have thus altered the natural infiltration rate. It was very easy for, let's say, when there's a higher precipitation, for water to find itself deep into the aquifers. But as time goes forward, humans were building, constructing, and it becomes impossible for water to infiltrate into the large or into the deep aquifers. And today we are faced with a problem or natural disaster, which one of these natural disasters can be linked to urban drain. Some developed countries are adapting to climate change and its relative impact, like flood. That is, and urban tissues like drainage system, good drainage system, or high capacity drainage system have been put in place to mitigate, or not only to mitigate, but to adapt to this climate change or to adapt to the incoming flood. In the developing countries, as we all know, most of the countries and most of the cities in the developing countries do not have adequate flood, or sorry, do not have adequate drainage system to manage the flood. So this class actually, we are going to discuss on the not only on the design of a drainage system, but we want to also see how some factors, be it natural and man-made factors, can contribute to increase the profile of natural disaster flood. And we also want to discuss how we can design our drainage system, taking into consideration these natural and man-made features or these natural and man-made factors. Some of these natural factors, which we all know, one of it very important, is linked to precipitation. The high rate of precipitation, or how the intensity of rainfalls would depend would generally define the rate of natural disaster flood. The topography, we all know that cities on the lowland and cities on the highland, and seldom have flood compared to city on the basin or lowland cities. But however, cities and mountainous cities need good drainage system so that to better channel the water coming from the mountain, which is not the case in the developing countries. So we are going to discuss all these natural factors. We are going to discuss precipitation. We are going to discuss how we can take into consideration and topography, how we can take into consideration the land use, buildings, roads, and other concrete pavement. Yes. And the land use actually will enter into man-made features. So we are going to discuss how these factors are going to affect our design, our drainage system design. Of course, when we are working with drainage system software like HECRAS and other drainage system software, all this analysis or all these factors are taken into consideration. Climate change or future climate change effect are all taken into consideration before we model or design a drainage system. Now, let us see the effect of urbanization on urban drains. We have to earlier discuss, and we talk of increased runoff. Yes, and when buildings have been constructed, all the urban tissues have been put in place, building roads and all the like, and it makes the surfaces becomes impervious. That is, it reduces the rate of infiltration. As the rate of infiltration is being reduced, hence the runoff is increased. Now, when the runoff is increases, there will be that high tendency of flooding. And also, not to mention that many urban drainage systems are outdated and may not handle the increased volume of water. Yes, and drainage system that and drainage system that were constructed, let's say in the late 60s, cannot handle the volume of water now now in 2000. Why? First, the rate of infiltration of water has been reduced into the ground. Then second, we also have the climate change. We are talking about climate change effect. The rate of the increase, the intensity of rainfalls keeps on increasing. And when that happens, of course, it's a cycle, increases runoff. And when there's a high volume of water and there's a small drainage system, it cannot hold the water. And we start talking about flood. The another effect of urbanization on urban drains, yeah, water quality deterioration. On the pollutant loads, urban runoff often contains pollutants such as heavy metals, oils, and nutrients from fertilizers. Impact on water bodies. Polluted runoff can degrade nearby rivers, lakes, and waterways, harming the aquatic ecosystem. Yeah. So here we are talking about, we are seeing the importance, actually here we are seeing the importance of construction or the existence of adequate drainage system. We are seeing under the effect of of the inexistence of drainage system of an adequate drainage system, like water quality. We are talking about erosion and sedimentation. Like if you come here to the city of Limbe, you will discover that most of the coastal areas have been are facing a stage and an erosion stage due to flood. Now, reduce groundwater water research and recharge. Reduce groundwater water recharge. Yeah, and this also goes in line to discuss about the natural disruption of the natural cycles of water. We know when rain falls, it filtrates into the ground, and after that, and we can have groundwater, which and groundwater. When we talk about water resource management, we are going to see how water can be used. Groundwater can be used as a good source of potable water, but because of the reduced rate of infiltration, we are now facing the problem of reduction of groundwater recharge in most cities. It is even more severe in the developed world. Now, here we are going to see some cities and some cities in Cameroon because of the inexistence of drainage system, adequate drainage system, and those cities cannot handle the intensity of rainfall, and those cities suffers from the natural disaster flood, like the city of Yaoundé, where we constantly have flood. The city of Yaoundé is a mountainous city. Generally, the general topography is a mountainous city. So all those localities that are somehow like a basin or in the lowland always suffers from flood. Like if you go towards the post in Yaoundé, like this image was taken towards around the post in Yaoundé. Whenever there is during the rainy season, this area suffers a lot from flood. And this it is true that we have flood everywhere in the developed and in the developing nation, but the problem we are facing in most cities in the developing nation is the inexistence of drainage system and also the capacity of this existing drainage system to hold water. Yes, and there again we leave from Yaoundé, we move to the economic capital of Cameroon, the economic capital of Cameroon. Here in the economic capital of Cameroon, we're going to see that the drainage system, the width of the drainage system, most of the drainage system that exists in the economic capital of Cameroon, it's very difficult to see a drainage system with width of 4 meter and depth of, let's say, depth of 3 meter. It is very difficult to see such drainage system. We know that the city of Douala it's a lowland, and it's like you also notice that if you've paid a visit in Douala, you will notice that the city of Douala is highly constructed. That means when there's a high volume of water from rain, it becomes very difficult rain to for the rain to even infiltrate the ground. Even if the water infiltrate the ground, at some point the water table becomes saturated. You understand? So in the city of Douala, we need very good drainage system that can we can use to adapt to the climate change effect. Then when we look down, we see effect of flood in Boya. Yeah, also the town of Boya, if you walk around, you will notice that the town of Boya, if you walk around like along the street of Boya, you will notice that most of the localities of Boya do not have drainage system. And that is very dangerous because when there is this high rainfall and water leaves the mountain with this high velocity, since it is descending, and it creates a lot of disaster along. We see water carrying cars from one locality to the other. Yes. Then when we look again, we see on the down, we see another on the impact of flooding in the city of Limbe. Yes. If you come also in the city of Limbe, you are going to see that the characteristic that you are facing in Boya, in Douala, you are facing also in Limbe. In fact, most of the cities in the developing nation lack the adequate, or most of the cities that we are talking about in existence of drainage system. Now, and if we look up here, we are going to see on the old degraded drainage system in the capital city of Yaoundé, that's around Corbiso. And you see that this was an old system, drainage system that was constructed maybe some 30 or 20 years ago, and with time it has degraded. And when there's high rainfall, of course, it is going to overflow its bank and get into houses since the drainage system itself cannot hold any significant volume of water. If you look here, you will see a drainage system in the capital city of Yaoundé. Yes, the drainage system in the capital city of Yaoundé. This drainage system was constructed years back, which helps to channel the waters into the nearby and rivers. Now, if we look again, we have another problem in the urban waste, management of urban waste. That is a general problem we are facing here in Cameroon, that most of the drainage system. Of course, management of urban waste is a whole specialty that can be found in the civil engineering or environmental management. When we talk about environmental engineering, where urban waste is one of the big topics to talk about. Now we are seeing an image where most of the urban waste have been dumped in the drain, and it becomes impossible for water to find themselves to its destination. Now we are showing the city here. We are showing the city of Limbe, the city of Boya, We are seeing high densely constructed cities, but we are not seeing any way on the drainage system. Now, here we have an image. Here is an image of a drainage system, construction of a drainage system in a city. Yeah, we have a drainage system layout. Then we have how we are seeing down how the water is being discharged to rivers. Then up, we are also seeing industrial drainage system. So there's a way we are going to see how we can design. We can design. If we do not see this year, of course, next year, which will be entirely practical, we are going to see how we can design urban and sorry, industrial urban drainage system and normal urban drainage system in the town. How we can link or link it to on the nearby river streams. So here we talk about urban drainage and public health. And let's just in human terms, the most valuable benefit of an effective urban drainage system is the maintenance of public health. Of course, we know that when there is no urban drainage system, of course there will be high flood, and when there's flood, we can all relate to the impact or to the aftermath of every flood, which comes a lot with maybe a lot of malaria, which sometimes it goes into the potable water system and pollute the potable water. And at the end of the day, we start talking about cholera and the rest. So now here we are seeing the history of the history of urban drainage engineering. And we are going to see the evolution of drainage system modeling, how to design, of course. There are, in every domain in engineering, there is a history, there's a background history. So in the early, let's say the pre 20th century, based on the basic drainage techniques use of basic drainage technique. Normally, in those days, we use a gravity-based system and simple covered designs. Yes, they study the topography and they see the inclination of the topography, and they cannot design covered that will channel or that will control the water. So that's the meaning of use. That's the meaning of usage of gravity-based system. Then now in the 1990s, theoretical framework, we talk about theoretical framework development, the introduction of the introduction of hydrology, emergency of hydrology, emergency of hydrological concept, including runoff and precipitation relationship. So good. They now have to study, now have to start, they start thinking of a multi-criteria way or to look at the different factors that can affect drainage system or that can play a role when designing drainage system. They start talking about just talking about the precipitation, the rainfall, and the runoff, and they establish a relationship. And now, in the year 1930s, Akasaki early method of okay, stormwater, that was when they start doing the modeling of stormwater flow developed. Okay, then now in the year 1960s to 1980s, hydraulics and the modeling software, the advent of computer led to the development of software tools like for hydraulic modeling, such as okay, stormwater management model. Although it has been written, this one has been written 1960s to 1980s. This and the stormwater management model. It is a model that is together with HERCRAS. It is a model that is it is a system that is highly used today in engineering, despite the fact that it was written in the 1960s, it was developed in 1960s, 1980s. It is still highly used in engineering in most countries, or they can use civil to be but they highly use this one and HECRAS for modeling of drainage system. Then in the 2000 now we start talking about focus on sustainable drainage system. In this focus, a multi-criteria study was done. This is where they start integrating different technology. They start integrating GIS, geographic information system. Start integrating and remote sensing. They start integrating ecological, socio-economical, and all the like to start integrating it before designing a drainage system. And now today, nowadays, or in the future, and we are talking about big data and AI. Technology is evolving. We are talking about big data, how we can collect huge data, mostly in large cities, how they can collect huge data like the spot height, generate spot height. And we know that if you want to generate spot height in a city, it can be millions if we are working with intervals of, let's say, every after 10 meters, we want to have spot height. We want to have the altitude XY of in the city. So at the end of the day, in the city, you can have millions of data. For you to manage that data, it becomes very, for a human being to manage that data with normal software, it becomes very, very difficult, sometimes most of the time impossible. So we call this type of data big data. Those are the very high voluminous data. We call them big data. So we are seeing how we can together we can have high voluminous data, and with AI we can model, or design a drainage system in a large complex city. But now presently what we are using, we use our normal software to design a drainage system in a local scale. That is, we can do it in a quarter, and from quarter to quarter, from quarter to quarter, we do a chain. Yes. But in the future, we are looking for a way to how we can work with big data and AI. Okay, in the next class, we're going to talk about approaches to urban drainage system. While talking about approaches to urban drainage system, we are going to discuss under the software used in drainage system and their functionality. We are going to see how to model drainage system. We're going to talk about stormwater management. We are going to talk about how to treat stormwater. We are going to talk about a lot of modeling as far as hydrology and hydrology is concerned, or hydrography. We are going to talk about we are going to talk on hydrology and hydrography, and we're going to do designs. Our course is we are going to do much of software. So we're going to work software design, most of it, but this we had to give this introduction so that we should see, and we should see the importance of what we are designing. Okay, so our next class today will be coming up another to finish to run up with the theory. We are going to have a next class, a next video, a short video like this one. Okay, thank you, and stay tuned.